Hello all, I am Devbrata Pal from IIT Bombay, India. So today I am going to present you about domain adaptive few-shot open-set learning. So this work has been carried out in collaboration with students and professors from IIT Bombay, Manipal Institute, and Purdue University. So we proposed DFSOS, where the queries during the meta testing time can come completely from a different domain. Let us say this painting domain, whereas the meta training time it use a different domain, let us say clipart domain. Now the queries in meta testing time are actually coming from both known classes as well as the unknown classes. So we should recognize these unknown target class queries apart from classifying the known class queries into one of the target domain classes. Now, DFSOS is quite a challenging problem formulation because FS standard FSL and FSOS does not consider the target queries are coming from a completely different domain. Also, DFSL it does not consider any unknown queries during the meta testing time. DFSOS has numerous applications. Let us say for self-driving cars, we can leverage plenty of gaming data, and these are all synthetic data. So we can learn what is known and unknown, and the same logic we can apply directly on the road while a car is driving. DFSOS can also be applied in recognizing the unknown animal species, unknown land cover objects, also novel virus detection, etc. So to solve that, we are proposing DAFOSNet, a novel architecture where during training time we leverage both source and target domain. And so support sample are created from the known classes, whereas queries are coming from both known and pseudo unknown classes for respective domain. They passed through to an augmentation process where image level augmentation happens with geometric transformation, followed by feature encoder produces embeddings. Thereafter, we propose two generative networks. So one generative network driven by small noise variance vectors produces pseudo process samples which are used to augment the closed space for respective domain. Similarly, other generator driven by high noise variance vectors produces pseudo open samples which are used to augment the open space for respective domain. Thereafter, the prototypes are actually updated with the batch norm parameters, shift and scaling parameters, and we minimize the global pause domain distance. And thereafter, the query distances from the respective prototype are actually computed. Those query distances are passed through outlier predictor and domain predictor to respectively predict whether that is query is inlier or outlier or it belongs to which domain. In the case of inlier prediction, further we obtain its final class by applying softmax over the query distance. We propose several novel metric losses. So prototype diversification loss is based on the triplet loss, where the same domain, same class queries are actually pulled, whereas the other class queries are pseudo unknowns and other domain queries are actually pushed. Then global cross-domain prototype alignment considers some updated prototypes with batch norm parameters. So the source domain overall global distance it has from the target domain is actually minimized. And then also in DAFOSNet to introduce two generator one given by two noise variance vectors. So the JDL and JDH or these two noise variance vector when they are very much close to each other, their generated samples SL and SH should be quite pushed away. Or that is why we enforce this regularizer. Overall, DAFOSNet beats the existing state-of-the-art FSOS, DFSL, and FSL methods by a large margin. We can see for 5-shot case almost 15% accuracy boost and 17% accuracy boost happen over the literature. Also, we extended our DFSOS evaluation against the generalized case where a target query can come either of the domain. In the case of global domain alignment based optimization, we observe the source domain queries are actually forming compact clusters. Target query are also forming the similar representations. Overall, we proposed DFS a novel problem formulation and it experimented with both standard case and generalized case. We introduced DAFOSNet having discriminative domain embedding space with several loss objectives. Further, we can perform meta training time multiple source domain optimization. We expect better accuracy in that case. Thank you.